My dear students, in the previous video, I have solved some problems in the exercise 13.1, and in this video also I am going to continue the same exercise 13.1. In this exercise, problem number 18, that is evaluate limit x tends to 0 ax plus x cos x by b sin x. That is the problem. Evaluate limit x tends to 0 ax plus x cos x by b sin x, that is equal to limit x tends to 0. If you take x as common in the numerator, that is x into a plus cos x by b sin x. And the next step, that is equal to, you can take this denominator b as 1 by b out of the limit, 1 by b into limit x tends to 0 a plus cos x, and you bring the numerator x to the denominator that is sin x by x. A plus cos x, by bring this x to the denominator of the denominator, that is sin x by x. Again apply the limit both numerator and denominator separately, that is equal to 1 by b into limit x tends to 0 a plus cos x by limit x tends to 0 sin x by x. Applying limit in the numerator, 1 by b into a plus cos x is cos 0 by limit x tends to 0 sin x by x is 1, by property it is sin x by x is 1. Again 1 by b into a plus cos 0 is 1. 1 by b into a plus cos 0 is 1. By 1 we cannot write. By 1 is a plus 1 only. So 1 by b into a plus 1 or a plus 1 by b. That is the answer. You can write it as a plus 1 by b. That is the answer for the problem 18. Next simple problem 19. Evaluate limit x tends to 0 x secant x. X into secant x, you can apply the limit x tends to 0 directly. The limit x tends to 0, apply x equal to 0, 0 into secant 0. Secant 0 is 1. Cos 0 is 1, therefore 1 by cos 0, 1 by 1, secant 0 is also 1, so 1 into 0 is 0. That's all about the problem. So, 19th problem over. Now come to the 20th problem. Evaluate limit x tends to 0 sin ax plus bx by ax plus sin bx, where a comma b and a plus b are not equal to 0. In this case, limit x tends to 0. I am dividing sin ax by ax. To compensate it, I multiply by ax plus bx. Similarly, in the denominator ax plus sin bx by bx. To compensate it, I multiply by bx. I multiply and divide by bx in the denominator. As in the case, I multiply ax and divide by ax in the numerator. To compensate this problem, I divide by x and multiply by x in the numerator. Similarly, I divide by sin bx by bx and compensate it, I multiply by bx. Now apply the limit, numerator and denominator separately. Apply the limit for the problem. So this is equal to numerator limit x tends to 0 sin ax by ax plus bx divided by limit, the numerator also, you apply the limit separately, limit x tends to 0 ax plus, you need not write apply the limit here, you apply the limit in this step, ax plus limit x tends to 0 sin bx by bx into dx. That is the problem. So this is equal to limit x tends to 0 or ax tends to 0 sin x by x is 1 plus dx. Here also you have one ax here. In the numerator also you multiply by ax. So this is ax plus bx. So 1 into ax plus bx. Similarly, in the denominator ax plus limit x tends to 0 sin bx by bx is sin limit x bx tends to 0 sin bx by bx, you can say this is 1 into bx. So that is plus b by x into a plus b. X cancel, you will get a plus b by a plus b is one answer. This is problem 20. Okay. Next one. Problem 21. The exercise problem number 21. Evaluate limit extends to 0 cosecant x into cot x. Minus cot x. See, you apply the limit, before applying the limit, you rewrite the problem limit x is 0 cosecant x by 1 by sin x minus cot x by cos x by sin x. So that is equal to limit x tends to 0. If you take sin x as common LCM in the denominator, you get 1 minus cos x in the numerator. That is equal to limit x tends to 0. 1 minus cos x is 2 sin square x by 2. Already you have seen in the 17th problem. 2 sin square x by 2 by sin x is 2 sin x by 2 cos x by 2. Half angle formula. 1 minus cos x is 2 sin square x by 2. Sin 2x is 2 sin x cos x. So similarly sin x is 2 sin x by 2 cos x by 2. 2, both the numerator and denominator cancel, and 1 sin x by 2 is also cancelled. You will get limit x tends to 0. Square is also cancelled. 1. We get 1 sin x by 2 by cos x by 2. Sin x by 2 by cos x by 2. Limit x tends to 0, sin x by 2, sin 0, 0, cos 0, 1. Limit x tends to 0, sin x by 2 is sin 0, 0, 0 by 1. Answer is 0. Answer 0. That's all. Next, problem 22. Problem 22, evaluate limit x tends to pi by 2 tan 2x by pi minus x minus pi by 2. Tan 2x by x minus pi by 2. That is the problem. Limit x tends to pi by 2, tan 2x by x minus pi by 2. Substitute x minus pi by 2 equal to y. From this, x equal to pi by 2 plus y. Therefore, as x tends to pi by 2, y tends to x tends to pi by 2, y tends to pi by 2 minus pi by 2 0. Therefore, the problem becomes limit x tends to pi by 2 becomes y tends to 0. Tan of 2 into x is pi by 2 plus y by x minus y by 2 is y. That is limit y tends to 0 tan 2 into pi by 2 is pi plus 2 into y is 2y. Pi plus 2y by y. That is limit y tends to 0 tan 180 plus theta. Third quadrant tan positive 180 does not change the ratio, therefore tan 2y by y. Tan 2y by y. So that is equal to limit y tends to 0, tan 2y is sin 2y by cos 2y into y. That is, you can take the limit y tends to 0, sin 2y by y, you take sin 2y by y. You keep as it is and you rewrite that 1 by cos 2y as limit y tends to 0, 1 by cos 2y. You separately write that cos 2y in a separate limit. Limit y tends to 0, sin 2y by y one limit into limit y tends to 0, 1 by cos 2y. So to compensate this limit, I am going to write limit y tends to 0, sin 2y by 2y. Then only it's become 1. Limit x 2y tends to 0, sin y tends to 0, 2y by sin 2y by 2y is 1. To balance it, to compensate, multiply 2 and divide by 2. And this is also limit 1 tends y tends to 0, this is 1 by cos 0. Cos 0 is 1. Therefore, this is 1 into 2. And this is also 1 by cos 0 is 1. So, right answer is 2. 1 into 2 into 1 is 2. That is about problem 22. Okay. Next, we will see the problem number 23. Problem 23 we are going to see now. Problem 22 over. Next, problem 23. Exercise problem 23. Find limit x tends to 0. Find limit x tends to 0, f of x, and limit x tends to 1, f of x, where f of x is f of x equal to 2x plus 3 if x less than or equal to 0, 3 into x plus 1 if x greater than 0. This is the problem. First we are going to see limit x tends to 0, f of x. For that, limit x tends to 0 minus f of x is limit x tends to 0. 0 minus is negative side of 0. That is less than 0. Less than 0 is f of x is 2x plus 3. Less than 0 is x is 2, f of x is 2x plus 3. Because 0 minus is negative side of 0. That is less than 0. Function is 2x plus 3. Applying limit x tends to 0. This is 0 plus 3. Answer is 3. Similarly, limit x tends to 0 plus positive side of f of x limit x tends to 0 plus 0, 0 plus is again 0, greater than 0, function is 3 into x plus 1. In this case, if you apply x equal to 0, 3 into 0 plus 1, 3 into 1 is 3. So from this we can say limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x, both are equal. Therefore, that is again equal to limit x tends to 0 f of x, the value is 3. That is the problem. Similarly, next case, next one, limit x tends to 1, that is 1 minus, limit x tends to 1 minus f of x is limit x tends to 1, 1 minus is greater than 0, that is 3 into x plus 1. The function is 3 into x plus 1. If you apply x equal to 1, 3 into 1 plus 1. Here, 3 into 1 plus 1, that is 3 into 2, that is equal to 6. Similarly, next one, right hand limit. Limit x tends to 1 plus f of x is again limit x tends to 1. 1 plus is greater than the 1, that is 0, 0. Greater than 1, that is 3 into x plus 1, that is 3 into, if you apply the limit x equal to 1, again 3 into 1 plus 1, 3 plus 2, 3 into 2, 6. Therefore, limit x tends to 1 minus is equal to limit x tends to 1 plus f of x. They are both the left hand and right hand side limits are equal. Therefore, limit x tends to 1, f of x is 6. This is the second answer. First one is 3, second one is 6. Let's solve about the problem. Limit x tends to 0, f of x is 3. We have seen just before. And limit x tends to 1, f of x is 6. Let's solve about the problem 23. And I will stop here. And the next problem number 24 we will continue in the next video. Thank you.